Hi guys, the last few months, as you would have noticed, have been obtrusively quiet for me and for most of the world. We are in the middle of an unprecedented attack by something about 10 million times smaller than us. This tiny thing called a virus has brought the whole world to a stop, literally. Most of you who are hearing this are perhaps locked inside their homes or elsewhere. It is at this time that some people are out there finding a cure for this disease. People across the world are looking up to scientists to come up with a cure. But if history is to be believed, science has always come out with a solution. It is in this light that I decided to start a series of podcasts. I, being related to the field of physics, would like to share with all of you some of the greatest experimental feats achieved by physicists across the century. I would share how these experiments would solve age-old problems and help shape the future world. This will be more like a story of how scientists, when called upon, cured long-standing problems with sheer brilliance and simplicity. In these tough times, I hope that this series of podcasts somehow instill a hope amongst you. That like every time, this will also be cured. Here we go. Imagine yourself in the early 1900s. The world of physics has been turned upside down. Something called the quantum theory is replacing the old understanding of physics. Whatever we knew seemed incomplete. As new technologies emerged, new problems came into view. One of the most striking problems that was there was the internal structure of an atom. How does the atom look like from the inside? By this time, we knew that the atom wasn't indivisible, as Dalton theorized, but had subatomic components. One of these were discovered to be electrons, the negatively charged particles. But since atoms on their own never showed any charge, there should have been an equal amount of positive charges to cancel negative charge. But the major question was, how are these positive and negative charges arranged inside the atom? Up till then, there were no definitive model or understanding of the inner structure of an atom. All that was known was the size of an atom, which is about 10 billion times smaller than a centimeter. The most popular theory at that time was the plum pudding model, developed by Lord Kelvin and J.J. Thomson. Thomson, also the discoverer of the electrons, described the atoms like a pudding of positive charges where the electrons were spread like plums. Even though this model was popular, it wasn't a complete and satisfactory model. Many scientists rejected this model even then. To test this model and subsequently develop a better theory, a groundbreaking set of experiments were set up by Ernst Rutherford, Geiger, and Marsden. The experiments were deceptively simple, but the consequences were overwhelming. What the scientists did was shoot alpha particles, which were basically helium nucleus, towards a thin metal foil, and measured the angles by which these particles had deflected using a fluorescence screen. Just to say, if the Thomson model were to be true, the deflection of the alpha particles would be very small, fractions of a degree. This is because the whole positive charge is spread throughout the volume of the atom. Thus the force on a particle is very small. But what Rutherford and his co-workers found was something unprecedented. they found that majority of the alpha particles went undeflected, as if nothing happened. While some were deflected by a small degree, but the most important observation was that some particles were deflected by a large amount, to the extent that some particles were shot right back at the source. Now this wasn't possible with a Thomson ray. The very large angle of deviation just tells you that the alpha particle faced much stronger electrostatic repulsion than what is predicted by Thomson. Also, some particles were totally undeflected. This could mean the particles faced absolutely no force. This led to a very important conclusion. Atoms are mostly empty space. Yes, you must have heard it. After a series of experiments across 5 years, it was indeed established that the atoms wasn't at all like the plum pudding. In fact, it consisted of a nucleus, which was the positive pole. It was at this nucleus that most of the atom's mass were concentrated. This nucleus was surrounded by electrons. Rutherford didn't stop there. He also developed the scattering formula. I won't go into the details but just that this formula was also verified in subsequent experiments. So to put it in context, this was before we knew anything about protons and decades earlier than neutrons. People were struggling to find the answer to the age-old problem. Rutherford, Geiger, and Marsden gave us the answer. The experiments they devised were elegantly simple. The results they found were conclusive. People now had an idea of how the atom looks from the inside. It's almost as if we took a peek at an atom. Momentarily, of course. The simplicity of the experiment also adds to the fact that science is indeed simple and elegant. The Rutherford model was, of course, not the perfect model, as we know now. It also had its flaws, which required quantum theory to intervene. But what these experiments did was correctly, to a certain extent, model the subatomic space for the first time in history.